Alright, so when the switch is open, we can treat this circuit as just resistors in series. And this resistor right here represents the internal resistance of the battery. And it tells us in the question that the current is 0.369, and we know that the current will be the same throughout since they are in series.
Okay, so that was the current for when the switch is open, but now we're going to try and find the total current when the switch is closed. So when the switch is closed, that allows charges to go through both halves and come back through, so we're going to have a different total resistance. So, but however, we know by the junction rule that the same voltage is going to go through this resistor that goes through this resistor. So we know that the voltage, if we'll call this one 1, this one 2. So we know the voltage of 1 is going to be equal to the voltage of 2. So because of that, we know that the current of 1 times the resistance of 1 is going to equal the current of 2 times the resistance of 2. And then, so then we can plug in the values because we know that the problem tells us that the current through the 30 ohm resistor, 30 ohm resistor is 0.35 amps. So so I1 is 0.35 times 30 equals I2 times 42, and when we calculate that off, you get I2 is equal to 0.25 amps. And then now we can go back and see the total current through the internal resistor when the switch is closed. So since that's in series with this combined, it would be this current plus this current, which would be 0.35 plus 0.25 amps equals the current through, or the total current. Equals I total. And since we know that that would make this 0.6 amps.
Okay, so now we're going to use the loop rule, which says that the change of voltage equals 0. So for our first loop, we'll do it with the circuit open. So it's going to go from here around to this way. So first we have our voltage source, and then minus the change of voltage here, which is going to be 0.359 amps times the resistance, which is still unknown. So we'll put that as our internal resistance. And then following the loop, we're going to do that change of voltage, which is 0.359 again, times 30 ohms. And then that's going to equal 0. And then for our second loop, it'll just be the closed circuit, so we'll still go around this way, but now this is closed, which is going to change the current that goes through here. So our second equation will be the voltage minus 0.6 times the internal resistance minus this one here, which the current is now 0.35, and then times 30 ohms again equals to 0.
Okay, just a quick note. We wrote this wrong in the last one. It should be 0.369, not 0.359. So, anyway, now we're going to solve out to find I, R, and V. So, we're going to solve for the voltage in this equation. No, this equation, sorry. Voltage equals 0.369 RI. Oh, not RI. Yes, RI, sorry. Plus 0.369 times 30. So now we're going to sub this into the second equation so we can find RI. So now this is just algebra, so we're going to get negative 0.231 Ri is equal to a negative 0.57. So dividing that out, Ri is equal to 2.47 So now we're going to take the RI that we found, plug it back into this equation in order to solve for the voltage. So your voltage is equal to 12